This last part will be on hyperbolic. All right, let's look now at the first one. These are the ones you need to memorize. The derivative of the sine is cosine. The derivative of the sine is cosine. And what this means is times the derivative of the angle out here. So the derivative of sine is cosine. The derivative of some object is the cosine of that object. Then times the derivative of the angle. So let's look at this example right here. Y is equal to sine of 5x squared. Therefore, y prime is equal to the cosine of 5x squared. Write it all down. Then times the derivative of the angle. Listen to me one more time. The derivative of sine. I don't have to read this out. The derivative of sine of anything is the cosine of that same thing. Then times the derivative of the angle. So what we finally do, you need to learn to come back and put these things out in front of the trig function. All right, the next one to memorize. The derivative of cosine is minus sine. The derivative of cosine is minus sine. The derivative of cosine is minus sine, and then times the derivative of the angle. So let's look at this example. The derivative of this would be y prime is equal to minus sine of, and then times the derivative of the angle. So the final answer, we should learn to put minus 3 sine of 3x. All right, the next one to memorize is tangent. The derivative of tangent is secant squared. The derivative of tangent is secant squared. Just the derivative of tangent to the first power is secant squared, and then of course times the derivative of the angle. So let's come down here then. And so y prime would be secant squared of x times 1. All right, next one to memorize. The derivative of cotangent is minus cosecant squared. The derivative of cotangent is minus cosecant squared. The derivative of cotangent is minus cosecant squared times the derivative of the angle. So looking at this example, y prime would be minus cotangent of the angle times, the derivative of cotangent is cosecant squared of the angle times the derivative of the angle. Let me go over it one more time. The derivative of cotangent is minus cosecant squared of the angle. This all goes together. You cannot separate these words from this x. This has to go together. The derivative of cotangent of this is cosecant of that squared minus times derivative of the angle. So final answer would be minus 10x cosecant squared of 5x squared. All right, next one to memorize. The derivative of secant. The derivative of secant is secant tangent. Derivative of secant is secant tangent times the derivative of the angle. So if we had the secant of 3x, then the derivative of that would be 3 secant of 3x tangent of 3x. The derivative of secant is secant tangent. Then times the derivative of the angle. You can go put it in front. All right. Last one to memorize is the derivative of cosecant is minus cosecant cotangent. The derivative of cosecant is minus cosecant cotangent. Then times the derivative of the angle. All right, the last one here, the derivative of this would be minus cosecant cotangent times 1. So therefore the answer is minus cosecant cotangent. Now those are the 6 to memorize. Now let's look at some examples. All right, let's look at this number 1. Okay, taking the derivative. Derivative of y is y prime. The derivative of sine is cosine. All of this goes with the cosine. It's all one object. Then times the derivative of the angle. Now this doesn't look good like that. It looks like that's the cosine of all this. And so that's why you should come down and rewrite it and move the derivative of the angle out in front. What I want you to see though is look, the derivative sine is cosine. The derivative sine of all of this is the cosine of all that. Then times the derivative of the angle. All right, next one. Y is equal tangent. So derivative of y is y prime, 1y prime. Derivative tangent is secant squared. Then times the derivative of the angle, which is 5 over 2 times the square root of x. Derivative square root of x is 1 over 2 times the square root of x. So again, you need to learn to rewrite this as all divided by 2 times the square root of x. Okay, next example. Now watch this one real close now. This starts getting confusing to students sometimes. The derivative of y is 1y prime. The derivative of this is the power rule. The power rule. So it's 3 times this object squared. It's the power rule of the sine of 5x. The power rule. Then you look back without the power and say what is the derivative of the trig function, which then would be cosine of 5x. Then times the derivative of the angle. Now listen and watch real close. A lot of students confuse this one. But here's what you do. You power rule the sine. You still have the sine there. You power rule the sine, then times the trig derivative. Derivative of sine is cosine, and then times the derivative of the angle. So the final answer is 15 sine squared times cosine. All right, let's look at the next example. Same concept. So here we go, very slowly. All right, it's the power rule of the tangent. The power rule is 5 times the tangent to the 4th power. Don't start taking the derivative of tangents yet. It's the power rule. That's all times all this mess. Then it's times the derivative of the angle, which is a product rule, which says, I'm going to write the first one down and take the derivative of the second one, which is 8x plus 1. Plus, I'm going to write this one down and take the derivative of the e to the x. So the derivative of the e to the x itself, and so I write down the 4x squared plus x minus 2. All right, I want you to look back over this one again. The derivative of the tangent to 5th power is 5 times the tangent to the 4th power. Don't go put c. Oh, we forgot the derivative of the trig part. Aha. So we've got to have in here the derivative of the tangent, which is secant squared of all this mess. All right, now, watch. The power rule, 5, reduce it to the 4th power, and then we're going to take the derivative of the tangent part, which is secant squared of all this mess. Then times the angle, which is what this part is. It doesn't make any difference the order that you write it all down, but you should have the power rule of the trig function done. You should have the derivative of the trig function done, and then you should have the derivative of the angle. And you notice I spread all this out to kind of keep it separate. This part, and then I leave a separation between here and here, and then a separation between here and here to point out this is the power rule of the trig, this is the derivative of the trig, and then this is the derivative of the angle. All right, let's now look at 4 more examples. All right, let's look at division. Okay, this is the quotient rule. So y prime is equal to, write the bottom one down, so it's a cosine of x squared times the derivative of the top. What's the derivative of cotangent? Derivative of cotangent is minus cosecant squared. Now watch. The derivative of cotangent is cosecant squared, minus cosecant squared. Then we take the derivative of the angle, which happens to be the cosine of x. This parenthesis is the derivative of cotangent, minus cosecant squared. Then the derivative of the angle is derivative sine of x cosine, minus, okay, we write the top one down, cotangent of the sine of x, and take the derivative of the bottom one. The derivative of the bottom one, the derivative of cosine is minus sine, times the derivative of the angle, which is 2x. All right, now watch again. I write the top one down and take the derivative of the bottom. The bottom is cosine. Forget about the x squared. It's cosine. So the derivative of cosine is a sine, negative. Then times the derivative of the angle, all over the bottom one squared. All right, look at the next example. The derivative of this would be y prime. The derivative of e to some power is itself. Just copy it down. And then you go up here and take the derivative of the power. So this answer would be minus sine of x e to the cosine of x. All right, next one. I want you to watch a little trick that happens on this every time. The derivative of secant to a power. All right, so that's y prime is equal to power rule. Power rule. So here's the power rule. Okay, move the 2 down, make a 1. Then you take the derivative of the secant, which is secant tangent. But look what happens. You end up back with a secant squared. You end back up with a secant squared. So look what happens up here. If you had secant to the 5th power, then this would be 5 secant to the 4th. Then times the derivative of secant. Then when that multiplies back, you end up with the power you had to start with. Very interesting relationship that helps you when you go to integration later. Okay, let's look at the last example in the notes. This is what's called implicit differentiation. We have x and y's together, but that's no big deal. Here we go. The derivative of sine is cosine. The derivative of sine of all this is a cosine of all that. Then we take the derivative of the angle, which is a product rule. Write the x down and take the derivative of the y squared, tag on a y, plus write the y squared down, take the derivative of the x, which is 1. This is the derivative of the angle, equals. Now, the derivative of tangent squared is the power rule. So that's 2 times tangent to the 1st power, then times the derivative of tangent, which is secant squared, then times the derivative of the angle, which is 2 plus y prime. Okay, this should be enough examples to help you do the derivative of trig functions, remembering just the concept of memory and the power rule and the derivative of the angle. The derivatives of hyperbolic functions. Hyperbolic functions. This is going to be very, very similar to the derivatives of trig functions. So let's look at the functions that you need to memorize the derivative of. Okay, we're looking the derivative of the hyperbolic sine of x. This is the way that it's read with the sin h is the hyperbolic sine of x. And just like regular trig, the derivative of the hyperbolic sine is hyperbolic cosine. All right, let's look at the next one. The derivative of hyperbolic cosine is hyperbolic sine, positive. There's the difference between trig. The derivative of hyperbolic cosine is hyperbolic sine. All right, the next one. The derivative of hyperbolic tangent is just like before, secant squared. Derivative of hyperbolic tangent is hyperbolic secant squared of x. All right, let's look at the last three now, looking at cotangent. Again, just like before, the derivative of hyperbolic cotangent is hyperbolic cosecant squared minus. All right, the next one. The derivative of hyperbolic secant is secant tangent, just like trig. Whoops, wait a minute, minus sign. Derivative of hyperbolic secant is minus hyperbolic secant, hyperbolic tangent. All right, and the last one. Hyperbolic cosecant is minus hyperbolic cosecant, hyperbolic cotangent. Now, here's the way I think you should memorize the hyperbolics. The first three are plus and the last three are minuses. In other words, the derivative of hyperbolic sine is positive cosine. Derivative of hyperbolic cosine is positive hyperbolic sine. Derivative of hyperbolic tangent is positive secant squared. Then the last three, hyperbolic cotangent, hyperbolic secant, hyperbolic cosecant, are all negative. Same rules except the plus and minus signs as trig. All right, in your notes there, let's look at underneath the hyperbolic sine one. So let's take this. If we have y is equal to the hyperbolic sine of 5x squared, then y prime is the derivative of the hyperbolic sine, which is hyperbolic cosine, and then times what I call the angle, times this object out here. And so that would be 10x. So therefore, we would write down that this is 10x hyperbolic cosine of 5x squared. So it's just like the trig. The derivatives of these are the rules. The rules, which are the derivative of sine is cosine, derivative of cosine is sine, derivative of tangent secant squared, derivative of cotangent minus cosecant squared, so on and so forth. Then it's times the derivative of this object out here, the angle or whatever you wish to call this. All right, next one. Y is equal to hyperbolic cosine of 3x. Then y prime is equal to positive sine, hyperbolic sine of 3x times the derivative of the object. All right, the next one. Cross there at the top of your notes. Y is equal to hyperbolic tangent of x. Therefore, y prime is equal to hyperbolic secant squared of x times the derivative of x, which is 1. Okay, now the next row, hyperbolic cotangent, derivative of hyperbolic cotangent is, let's see, what was it? It was minus, and it was cosecant squared, and then times the derivative of the angle. So it's minus 10x hyperbolic cosecant squared of the object times the derivative of the object. All right, next one there. Y is equal to hyperbolic secant, so y prime is equal to minus, I'm going to leave a space here, hyperbolic secant, hyperbolic tangent. Excuse me, let me rewrite that a little better. Hyperbolic tangent, then times the derivative of the angle, which is 3. Okay, and the last one there, derivative of hyperbolic cosecant of x is minus hyperbolic cosecant, hyperbolic cotangent. All right, now these are the ones you need to memorize the rule. The derivative of hyperbolic cosecant, memorize. Minus cosecant, cotangent. The derivative of hyperbolic secant is hyperbolic secant, hyperbolic tangent. The derivative of hyperbolic cotangent is cosecant squared, negative. The derivative of hyperbolic tangent is hyperbolic secant squared. The derivative of hyperbolic cosine is hyperbolic sine. And the derivative of hyperbolic sine is hyperbolic cosine. Now let's look at some examples. Okay. Y is equal to the hyperbolic sine of all that. So the derivative is y prime, derivative of y is 1y prime, derivative of hyperbolic sine is hyperbolic cosine. And then I just write all this down. And then times the derivative of this object right here, which happens to be 2x plus 2. Now, this doesn't look good written like this. This looks like it's the hyperbolic cosine of all this, and that's why you should take the derivative part and go rewrite it in the front and write y prime is equal to 2x plus 2 times the hyperbolic cosine of and this is a much more clear way of writing your answer. Alright, let's look at the next one. Y is equal to the hyperbolic tangent of the object. So let's see, derivative of y is y prime, derivative tangent is secant, hyperbolic secant of whatever the object is, times the derivative of this. Well, the times derivative square root of x is 1 over 2 times the square root of x. So the 5 stays up here, and then it's 1 over 2 times square root of x. Therefore, we should write our final answer is 5 times hyperbolic secant of the object divided by 2 times the square root of x. All right, let's look at example number 3. All right, this is where you have to watch, pay very close attention to what's going on. This is a power rule of the hyperbolic sine. So therefore, you power rule first. So it's 3 times hyperbolic sine squared. Power rule the sine first. Quit looking at the hyperbolic sine and look at the power rule. So it's 3 hyperbolic sine squared, and then you look at the derivative of the hyperbolic function, which is cosine, hyperbolic cosine. And then you look at the angle, or the object out here, times 5. Now watch this. Most students foul this up by coming along and doing the power rule and then going and changing this to cosine. You don't do that. You power rule the hyperbolic function that you have, power rule it, write it all down, and then it's going to be times the derivative of the hyperbolic function, and then times the object or the angle. So simplifying all this, this comes back together, and so y prime is equal to 15 hyperbolic sine squared of the object times hyperbolic cosine of the object. Now pay close attention to that one and watch for it and don't make the mistake that's common. All right, let's look at number 4. Okay, this is a big long one here, but it's still by the rules, all right? So let's take the derivative of y is y prime, power rule. It's the power rule. So we're going to move the power down and write down the same trig function to the 4th power of all this mess, e to the x squared times 4x squared plus x minus 2. Okay, all that. That's the power rule. Now we go take the derivative of the hyperbolic function. So therefore it's going to be secant squared of all this mess. Then times the angle, the object. Well, that's a product rule. So that's going to be times, all right? Write the first one down. This is e to the x squared. So first one down and take the derivative of the second one, which is 8x plus 1. Plus, write the second one down, which is 4x squared plus x minus 2, times the derivative of the first one, which is e. Derivative of e is itself, times the derivative of the power. So looking at your notes, look at this one and check it out. Make sure we have all the rules. Let's go back and look at it again. So what we're going to do is take the power rule. We're going to move the 5 down, raise to the 4th power, and write all that stuff down. So we're going to take just what we have all up here beginning with, except it's going to be 5 to the 4th power. So that's the power rule. Then we take the derivative of the hyperbolic function. Derivative of tangent is secant squared. Then we take the derivative of the object, which is a product rule. All right, now let's look at example 5. Okay, we have y is equal to hyperbolic cotangent of some object. This object happens to be regular trig sine of x. Hyperbolic cotangent of some object over hyperbolic cosine of some object. That object happens to be x squared, but it's still hyperbolic cotangent over hyperbolic cosine, excuse me. Now, quotient rule, division rule. So what we do is write the bottom one down first. So we write the bottom one down and take the derivative of the top one. The derivative of the top, the derivative of hyperbolic cotangent is hyperbolic cosecant squared negative. Hyperbolic cosecant squared negative. That's the derivative of hyperbolic cotangent. This is just the object. Then you take the derivative of the object. The derivative of sine of x is a cosine of x. But again now, this is the derivative of the hyperbolic cotangent. Then we take the derivative of the angle, the object here, and that's where that comes from. Then minus. Okay. Now we write the top one down and take the derivative of the bottom one. The top one is hyperbolic cotangent of sine of x, and we take the derivative of the bottom one. The derivative of the bottom one is hyperbolic sine. Okay? Positive. Okay? So the derivative of hyperbolic cosine is a positive hyperbolic sine of the object. Then the derivative of the angle, which is 2x. All over the bottom one squared. The bottom one squared. This is just part of the angle out here. All right. Now let's look at number 6. We have e to some power. The derivative of e is itself, so there's e to that, times the derivative of the power, which is positive hyperbolic sine of x. All right, let's look at the next example. Secant squared, hyperbolic secant squared. Power rule, move the 2 down to the 1st power, then times the derivative of the trig, the hyperbolic function. The derivative of hyperbolic secant is secant tangent. So it's the power rule, then the derivative of the hyperbolic function. Okay, now this multiplies back together and gives you back a square. That's kind of odd, but it works out that every time. If you take the derivative of hyperbolic secant to the 5th power, you'll get 5 hyperbolic secant to the 4th times the hyperbolic secant times hyperbolic tangent, and this will come back to be secant to the 5th again. Okay, let's look at the last example in the notes. This is what's called implicit differentiation. We have the hyperbolic sine of equal hyperbolic tangent squared of some object. So let's go over here. The derivative of hyperbolic sine is hyperbolic cosine of the object. There it is. The derivative of hyperbolic sine is hyperbolic cosine. Then we take the derivative of the object, which is a product rule. Take the derivative, writing the y squared down, take the derivative of x. Is 1 plus writing the x down and taking rid of the y squared is 2y, and we tag on a y prime. All right, let's look at the other side. Power rule. Power rule. The derivative of hyperbolic tangent squared is we move the 2 down, make this a 1, so that's the power rule. Then we take the derivative of hyperbolic tangent, which is secant squared, hyperbolic secant squared. So this is now the derivative of the tangent. Then we take the derivative of the object, which is 2 plus, and we tag on a y prime when we take the derivative of y. All right, this concludes then the table on taking derivatives of hyperbolic functions.